Hi, folks, welcome back. So, the other day I wrote a blog post about how I used a relatively simple reflection technique to save on my own agent's token use. And this is a simplification of this harness compiler idea I've been talking about. I'll leave links to all that below. But what I didn't talk about in this article, because that was meant to be a very concrete, relatable example, but now I want to zoom out a little bit. What I didn't talk about in that article was, look, if you have a task or a workflow that you want to build an AI agent for, how should you be decomposing? So cost is a big deal now. Everyone is finally waking up to these huge AI bills and they want to save on those AI bills. And all the current discourse is unfortunately all around model routing. I don't think that's quite the right technique. It helps a little bit, but fundamentally, I don't think that's the right technique. So, how should we think about it? I think we need to think about AI token usage along two dimensions, and then that'll give us a nice two by two, and we can talk about that a little bit. So, the two dimensions, I am calling them repeatability, and the other one is difficulty, cognitive difficulty of the task. So difficulty intuitively should be pretty easy to understand. It just means if you were to just think about it from a cognitive point of view, how much intelligence does this task need? How difficult is that task? Repeatability is a different axis. What I mean by repeatability is if you perform this task many times or this workflow many times, how much similarity will you see in those executions? So you might have to do a lot of reasoning, a lot of thinking at the beginning or during the first few runs. But say you are doing this workflow using an AI agent for a few months and you look back at all those traces. How different are those traces going to be from day to day? Or are they going to go down the same well-trodden paths? That's what I mean by repeatability. And so you can make a two by two, low, high, low. And then let's look at the easy one first. If you have a task that is not cognitively challenging, it's not difficult, but also its repeatability is low, which means that every time you run this task, you're going to need some reasoning, planning, language understanding. You're going to need LLM calls. But since it is not cognitively challenging, you can just use cheat models. On the other hand, if you have a task that is very challenging, it has very high difficulty, but also it's not repeatable in that every time you do it, there's something about the task or its inputs that needs novel reasoning and planning. So there's not much repeatability in that even if you run this task 100 times, the execution traces every time look different and there isn't any kind of repeated well-trodden path. So for this kind of a problem, you basically just need to use frontier expensive models. There's no way around it. So use Fable 5 for every time you need to execute this kind of a task or workflow. All right, let's look at some of these other quadrants because that's where it gets interesting. So say you have a task that is not difficult, low in difficulty, but it is very repeatable in that if you run it a bunch of times, you'll see it repeat its reasoning and come to the same conclusions. This is the example I gave in this blog post, where after it runs a bunch, you can see it doing the same things over and over again. And in fact, a lot of the things that it does can be captured in deterministic code. So what you need for this is you need some kind of a specialized harness. And this is what I've been talking about. If you really examine a task and break it down, you either break it down yourself or you look at historical traces of how an agent broke down the task. You can very quickly distinguish the steps that actually need LLM calls. Maybe they need it for understanding natural language or synthesizing natural language, or maybe you need an LLM call for reasoning and planning and tool calling, that kind of stuff. But often, if you look at enough traces, you can tell those apart. And then all the other steps, almost always, that don't need LLMs can just be written as deterministic code. And that's basically what a specialized harness does. The core thing a specialized harness is doing for you is separating these tasks that actually need LLM calls from the tasks that can be crystallized or captured as deterministic code. So in this quadrant, if you have low difficulty but very repeatable tasks, you can use a specialized harness, and for the places where it does need LLMs, you can have it call cheap models. So a specialized harness with cheap models. What about this last quadrant where the task is difficult, it needs a lot of cognition, but it is also repeatable? And what you can do here again is still use a specialized harness, but it's calling frontier models with the assumption that the first few executions used a frontier model because it is a challenging task. You need a frontier model to do a bunch of reasoning and planning, at least for the first few traces, before you can look back and reflect on all these traces and see which steps actually need a model versus which can just be reduced to deterministic code. So this is why I keep saying that routing is not quite the solution. Model routing is inadequate because the current paradigm very much is, if you look at all the suggestions out on blog posts or X or so on, the current suggestion is look at the workflow you're doing. If it's a simple workflow, send it to a cheap model. If it's a difficult workflow, send it to an expensive model. And it's not that straightforward. You really have to look at the entire workflow end to end and decompose it into its constituent steps. And I think this separation into these two separate axes, the cognitive difficulty of the task versus how repeatable it ends up being, might be a more nuanced and more useful way to look at it. But I think in all these cases, specialized harnesses have a very important role to play in getting great performance without paying the frontier API token prices. All right, so I hope that mental model helps. And if you like content like this, consider subscribing, like the video, and I will see you in the next one. Thanks.